Factoring perfect square trinomials. What is a perfect square trinomial? It is a trinomial whose factorization is the square of a binomial. So it's something like x squared plus 6x plus 9. If you factor that, okay, two numbers are multiplied to 9 and add to 6. 3 and 3, they are the same sign, and the middle sign tells us so they are both positive. Well, that's really x plus 3 quantity squared. So it's the square of a binomial. So how do we recognize one of these guys? Well, let's go back to a general one. A plus b squared is a squared plus a times b doubled plus 2ab plus b squared. Now if you're going, wait, what? How is that? Then remember that it's the square of a binomial, means to multiply something by itself. Let's FOIL that out. A times a, first a squared, outer plus ab, inner plus ba, which we will write in alphabetical order, plus ab, last plus b squared, which becomes a squared plus 2ab plus b squared. So what are we looking at in a perfect square trinomial? The first term is a perfect square. It has a square root. The last term, it's positive, and it also has a square root. And the middle term, really should have been up here, I guess. The middle term is double the square root of this times the square root of this. So if I have something like x squared plus 10x plus 25, I need to recognize this is a square. Its square root is x. This is a square. Its square root is 5. 5 times x, 5x doubled is 10x. And say, this is a perfect square trinomial, and its factorization is x plus 5 quantity squared. X squared minus 14x plus 49. Again, lead off with a perfect square. Got a perfect square here. The square roots, x, 7, that's 7x, doubled 14x, equals x. Now in this case, that's a minus 14x, so it's x minus 7 quantity squared. Right, x squared minus 7 doubled minus 14x plus, because you are multiplying negative times a negative, plus 49. Okay, they can also look a little more difficult. So how am I going to manufacture one? Well, let's say I take 6x minus 4y, and I want to square that. I will get square of this, 36x squared. This times this, negative 24xy, doubled, minus 48xy, and plus the square of the last term, plus 16y squared. So what am I looking for? This has a square root. This is positive and has a square root. The square root of 36x squared is 6x. The square root of this is 4y. 6x times 4y is 24xy. And this is the doubling of that, minus 48xy. So then it will factor as 6x minus 4y quantity squared. Okay, let's try another one. Do I want to save the picture? No, I don't. So let's give you one that's fully done. So how about 100x squared? And I'm going to make this up. So plus 50x plus 25. Square root of this, 10x. So what I'm going to start off and just assume this is a binomial, the square of a binomial. So this has a square root, it's 10x. This is plus, so everything's plus. Remember, this has to be a plus. So plus square root of 25 is 5 squared. Now, check it. 10x quantity squared is 100x squared. 10 times 5 is 50. Doubled is 100. Oh, wait, change. This needs to be 100x squared. Or sorry, 100x. And 5 squared is 25. So what I wrote didn't factor as the square of a binomial and probably didn't factor at all. So I had to modify it. Okay, let's come up with another one which hopefully works. So 49x squared. Now I'm going to make it up, so I'm going to go plus 64. Okay, square root of that is 7x. Let's throw a minus in there. It doesn't really matter if it's a minus or a plus. That only affects the sign I'm going to have here, which in this case will then be a minus. That's 7x. That's 8. 7 times 8 is 56. Doubled is 112. So there we go. Okay, does this have a square root? Yes, it does. What is it? 7x. 7x. Does this have a square root? Note, must be positive. Yes, it does. 8. 7 times 8 is 56. Doubled is 112. So the factorization. So look for perfect squares here and here. Verify by taking square root. 7x. 8. 7 times 8, 56. Doubled. Right? That's the 2ab. And there we go. So that's how we're going to, and of course it's the square of a binomial, that's how we're going to factor. So it's an easy factorization if it is in fact a perfect square trinomial. Difference of squares, where does that come from? Let's look at the general case. If I have a plus b times a minus b, so these are actually known as conjugates. Same two terms, once with a plus in between, once with a minus. If we multiply these out, first term, a squared. A times negative b minus ab. B times a, write them alphabetically, plus ab. And positive b times negative b is minus b squared. Simplify, a squared, these terms cancel, minus b squared. So, with the difference of squares, we have just that, a difference of squares. We have two terms which each have square roots, and we have a minus sign in between them. So let's pop down a bit, and let's do some. So how about x squared minus 9? Do they both have square roots? Yes. Square root of x squared, x. Square root of 9, 3. Right, x plus 3. X minus 3. And that's our factorization, right? Again, these are called conjugates, the same two terms, the x and the 3, once with a plus sign in between, once with a minus sign. How about 16x squared minus 25? Difference of squares, again, how do you recognize it? Two terms, both have square roots, must be a minus sign. If that's a plus, there is no factorization. How do you factor it? Square root of the first plus the square root of the second, square root of the first minus the square root of the second. Okay, let's try a few more. Let's do this one. X to the fourth minus 81. Does this have a square root? Yes. What is it? X squared. How about this? Square root 9. X squared plus 9, x squared minus 9. Now, if you ever see a fourth power, you have to be suspicious. Hey, is this a difference of squares? This one, no, you can't do anything with this, but that is also a difference of squares. So keep factoring. And that's why I always write the plus first and then the minus second, because maybe this factors. Does it? Yeah, difference of squares, x plus 3. X minus 3, so things must be fully factored. What else could we get? How about 75x squared minus 27y squared? Does this have a square root? Well, the x squared does, but the 75 doesn't, and nor does the 27. There are no square roots. But they're divisible by 3. Giving me 25x squared minus 9y squared. And this has a square root, 5x. And this has a square root, 3y. So the factorization, 5x plus 3y, 5x minus 3y. And so that's a factorization of some special bi or trinomials, binomials in the case of a difference of squares. So if there's two terms, the only kind of factoring you can do to it is common factoring. Well, that's for everything. You can always try and common factor everything. And then if there are two terms, they must both be squares with a minus sign between them, and you'll factor it as a difference of squares. Or if there are three terms and you got some big numbers running around in there, that can always be factored as we have done before. But if you recognize with the three terms that you have a perfect square trinomial, then it's an easy factorization, just as it's easy to square the binomial.